Yes, my name is Sandra, and I've been with Trackunit for almost 4 years. We've been using GraphQL for, I don't know how many years before I joined Trackunit, but only used it as an internal tool. Then around 3 years ago, we realized that we were trying to get external developers to develop on top of our platform. We needed some good API that they could call. So we started this work on building a public GraphQL, and now it's been live for a couple of years. Just maybe a quick question. How many have called the GraphQL API? Okay. Then I'm going to go through like the basics of GraphQL because it is slightly different from REST APIs. So with normal RESTful API, you have maybe different services. One microservice might contain all your players, and another one will have teams. And then you can, from the client, call /players and get player and /teams, something you get it. From a client perspective, that can be somewhat cumbersome because you need to do several API calls. And if you are in Australia and the server is in Europe, there's a latency back and forth. One way to solve this is having a GraphQL server in between. So the GraphQL server maintains a graph of all your data. And then from the client, you just ask the GraphQL server, please give me this data. It might give me a specific team and all the players on that team. Then it'll go and fetch that data from different microservices and then return the data in one result set to the client. Another way to express this is as graph. You have a book. Book has a link or some author. Also can have a call. So GraphQL has a schema definition language that looks something like this. You always have a type query. Technically you can call it something else, but it's a convention that it's always called query. And that's like the root. That's the entry points into a graph. In this example, you can ask for a book and give the ISBN number as a parameter. You can get the book back. On the book type, you have authors, which then refers to another type. On the author type, you can refer to other co-authors. That means that when you do a query, say now I want to have a book with this ISBN number, I can say from the client, what was special about GraphQL is that the client always says what it wants. So the client says, I want the title and I want the author's name. Then the GraphQL server returns there's a book. It has this title and these authors. And this will come in handy later when talking about how to operate a public GraphQL. But just briefly on our setup, we have several different graphs. We have, of course, our public GraphQL that are stitching together various subgraphs from our various domain services. But we also have a mobile GraphQL and we have an internal GraphQL that are exposing slightly different graphs. For example, for the mobile, we do some Bluetooth pairing and unlocking of machines. So there are some special calls to do that. And they're in a special graph just to keep them separate and only not pollute the public graph with those calls. When you operate a public API, normally you would do some kind of versioning because nobody gets it right in the first time. So eventually you're going to need to do some change. But with GraphQL, the general best practice, don't do it. It's typically, if you look at like the economics and logistics of doing an API change, if you are spending the time as the creator of the GraphQL API on making sure that it's backward compatible, it's usually less effort than having to go and talk to all the external developers using your API and getting them to upgrade to the new version. Therefore, GraphQL favors evolution over versioning. And there are some characteristics of GraphQL that makes it easier than for REST. The biggest one is that fact I told you that the client always says what it wants. And that gives much more features or ability for the server to serve what the client wants. Instead of with REST, where typically you can do stuff with the content type, but typically you just have a path that says, okay, I want team/22. And then, what does the client expect? You don't really know. So therefore, you typically for REST APIs have to have /v1/teams. But just before I dive in, they actually companies doing versioning for GraphQL API. One of the biggest examples is probably Shopify, where they run a 3-month release cadence. Then every 3 months, they release a new graph. And then you have 12 months to upgrade until it gets decommissioned. But that means you also have to go out to your developers and get them to upgrade and switch to the new version. With at least our external developers, none of our customers, they are really good at building big construction machines, but they're not software developers. So we see from time to time that they are hiring consultants to develop some software on top of our API. Once they're done, they're happy, the consultants leave, and then it just runs. If we needed to every 12 months go and make them hire consultants back in, update the client side, then it would just be a logistic nightmare. But so let's look at how you can do evolution. First of all, you need to be very explicit on your field names. So in this example, you have some type and you just have a user string. That's not very descriptive of what it actually means. It's better to have user full name, for example, because that allows you to evolve the API and say, maybe I want to have different properties. Maybe I want to have a whole new user object. So I can create a user, which is a whole new type, and then deprecate the user full name. Of course, it doesn't mean that it would go away by magic, but at least I can now communicate to my clients that this is a deprecated field you're using. And I'm not getting into a situation where I need to come up with some weird name that should be user object or something. Another way, or slightly similar example, in a list of users, make it explicit that now you are returning a list or an array of users. One thing where we are using the short names are when we are returning user connection. And that's because we've been using relay style pagination, which is a kind of like best practice for how to do nation GraphQL. In this case, you are returning an object. And it's a unique object for users. You have the ability to later on change that and say, now I want to add new fields. We actually use it the opposite direction. We have some old APIs that returned payload something, and now we wanted to morph them into relay pagination. But since there was an object that was returned, we could just take the same type, have the old fields and new fields next to each other, and then evolve the API. And once clients stopped calling the old fields, we could use those. Yeah, that's basically what I said. So another thing to look out for is nullable, actually not null types. So in GraphQL, you can specify whether a field is nullable or not. And it's nice from a client perspective. Okay, the user ID is always there. But what we typically say is if you have any kind of complex type, make sure to make it nullable, because since we have a Microsoft architecture in a distributed system, we cannot guarantee anything really. So if you're returning something and it doesn't, the server hosting that microservice went down or whatever, instead of if we should mark it as not null, then we need to throw an exception and don't return anything. We can return a partial result. It also means that we can start returning null for deprecated fields. It is slightly borderline because you are probably breaking some integrations when you start returning null. Maybe not breaking as in you get an exception, but maybe breaking as the user functionality no longer works. It is a good thing to have in your backend, especially you deprecated a field and you try to communicate and does this one client are not listening, then yeah, you can return null and get on with everything. On the server side, because the client is telling what it wants, and you can actually do multiple things to support legacy fields. One way to do it is to simply query what the client asked for. In Spring GraphQL, there's a data fetching field selection set that you can use and ask, okay, did the client ask for the legacy field? If it asked for it, you can do some legacy mapping stuff. If it didn't ask, you are not wasting time on doing that. For JavaScript, there's another library, GraphQL, Graph Resolve Input, that basically does the same thing. just TypeScript. Another way to do is use field resolvers. That's a technique used in many graphical implementation where you say that there's this type, in this case, my type, and I have some legacy field on it. Then I create a method for that field and null. And then the graphical runtime, if it detects that the client is calling this field, you'll call this method. I get, of course, the value of my type in as a parameter. And then I can do whatever mapping I need to do from the new my type object and then to the old legacy value. Another way we are doing sometimes is to split it out in a separate subgraph. Because we have this set up with schema stitching and multiple subgraph. What we can do is that we can take the legacy fields, put them in a separate subgraph, and then it's not cluttering the normal code flow, but you have the legacy ones and you can go and delete that once the client stops using it. We did that in one example where we had on an account, we had a field called account name. So you had the account name. That was silly. And we had this convention that usually most of our entities, they have a name. The account was just named differently for historical reasons. So we split it up and then we use schema stitching to stitch it together. So on the client side, that they can both call name and account name. Of course, account name is marked as deprecated. In the implementation, we use schema stitching, and the beauty is that we can ask for any value on the original or the new account objects. So on this object, we are asking for a selection set that has name in it, which is just, okay, we want the name. And then it's going to call this query on our subgraph with the name as a parameter. And when we look at the query, and we take this name, it's super simple. We just return an account object with the name. We take the account name and set the value account name. So with this, we have one code base with the legacies subgraph, and then we have another one with all the new Schema stuff. Another mechanism we use is, we call it the preview directive. It's a custom directive we invented. It checks when it gets a request, are any of these fields that you're requesting, are they marked as preview? So in this case, we have some field called custom fields, and we have added this preview directive. What that means that, of course, in the documentation, it generates this blob that says this is a preview feature. And if you want to actually use it, you need to pass a special header to preview and then a code name for that feature. What it allows to do is that we can ship the new features quickly to customers. So if somebody is asking for a feature and we are like, we want to deliver it soon so they can start integrating with it. We also want the right to make changes. We can ship it like that. And then later on, the preview directive, once we're satisfied with the API and feel that it's going to be stable. If somebody tries to call this and they don't write this header, you can see here the response. It still has this partial response where it gets all the other data, but custom fields with null, and there'll be an error that says, hey, you need to opt in to use this field feature. Yes. And of course, sometimes API breaks. We cannot avoid it. There might be security stuff that by mistake, some sensitive data was exposed, and we figure out this is really not that good to expose. Could all be performance issues if we by mistake exposed an unpaginated field that has millions of records. And yes, there's really no silver bullet when you get in some of these situations. It's just, we need to communicate. And yes, it takes months typically, but so you really try to avoid it. Sometimes you just need to break the API and then deal with the external developers using it. And how do we then figure out who are the external developers? And for that, we have a tool called GraphQL Pro. It's a multiple of things. It's a schema registry where different subgraphs, they can contribute to their schema. It also has policies and updations, and but keeps track of who are using every field, such that if we go into Hive, you can see how different graphs. Dive into public one. Say production. see insights. We have all the usage statistics. We can filter by clients. The way we name our clients is TU API, guide customer ID, and then a number more, which is the customer API token. So it's this one, they probably have 1, 2, and 3 API token. Then we can filter one and say, okay, percent to get ready. So I can select one client, I can see their call history, and I can also see what kind of queries they're making. And I can then click on one query and see how is this query performing. And I can also go and actually see the actual query they're making. It is a normalized query. So for example, you can see here the time zone is the empty string. That's every string just get set to the empty string. Numbers are set to 0 and so on. Just make sure that when it does statistics, actually aggregates. So all the instances of this query. We could also try. Yeah. In this case, there are actually multiple clients using the same query. What makes it really powerful is that we can dive in on the individual fields. So if we take our assets, so an asset in our world is basically like a construction machine or a construction tool or any kind of item we are tracking. Then we can see there are these different fields. We can see to the left here that the location is pretty popular. We can also scroll down and say, let's shoot the rental status. I want to do some changes to that field. Then I can go over here, I can hover and see, I'm in dock because rental status is only used by manager, which is our internal web UI. And then there's one customer using it. But if I need to do some changes here and I actually need to break this API and know that I only need to talk to one customer, that's nice when you need to do breaking changes. Because then you don't need to communicate to hundreds of customers, just need to go one customer and say, hey, you're doing this one query, this field needs to change. And we have an example of query they're making that then say how they can migrate to a different. The way we use is that our Java repos, they build in Circle CI. When they build, they upload the schema and validate. Validate, of course, that there are no breaking changes, but also validate our policies and splitting rules on the schema. We have our GraphQL router. It's written in using TypeScript. And what we're trying to build is such that it will pull in the schemas from Hive, and then publish and start. But what's happening right now is that we have a manual step where the Java developer needs to copy the schema into the GraphQL router repo. Hive supports this other flow, but it's just time on our part that's preventing us from switching to it. When it runs, it reports users back to Hive. That's just an example. It's checking the public and the internal GraphQL schema. So I already did demo. Yes. Another thing we're looking out for is performance. We try to estimate the cost of a query. So in this case, you're looking up, let's say you're looking up the title. It might have a cost of 1. And then you're looking up the authors. For every co-author, that might be a complex query, so that has a slightly higher cost. The reason for that is that you can do nasty stuff like this. So if the client starts asking for the authors and all of their co-authors and all of their co-authors, it increases exponentially and gets pretty expensive pretty quickly. So we are using a library called GraphQL Pro Complexity, where we have a directive that you put on the every field that has some cost to it. If you have a field that some type that loads 3 fields from a database, it doesn't have an individual cost on every field. You just put it on the upper level and say, loading a user cost 10. And then if you want the name and email address, that's the same price. You also put multipliers. Multipliers basically, if you have a paginated list and you ask for 10 items or you ask for 1,000 items, then the multiplier is the number of items you ask for. That limits the cost of a single query. And once we calculate that cost, we are then applying it in a rate limiting function where we look at what was the cost of all the queries the client were making within the last time window. And that rate limit also depends on the customer subscription they're on, but it allows us to control that there's not one client making a gazillion calls every second. that are super complex. Of course, if they're making a zillion simple calls, it might be okay, but it's like a weight balance for them to figure out if they want to do a lot of simple calls or they just want to do 2 complex ones. Yes. The final thing I want to talk about is our developer hub. This is the place to point out all our external developers. We're actually also using it a bit internally that we can point we have a new developer joins, we can point them here and say, hey, this is how you use the GraphQL API. What we have here, we have some documentation on what does it mean to do pagination in our GraphQL and so on. We have a really powerful tool, which is GraphQL Explorer, where I'm logged in. Oh, yep, I was logged in. And then I have a box of queries here, but you can then try and execute one and say, oh, that's the name of it. And you can also build the query. And so let's say we want the model and that's called it. Now I got the model of the Jenkins machine. Another thing we have is a GraphQL visualizer. It's drawing out our entire graph. We can filter it and you can say, now I want to look at an asset, and on an asset, I want to look at a list of events. And okay, what do I have on the events? Okay, I have active events. That's the one. And then you can traverse the graph and get a feel of what is available in this graph.